We're all recording.
Hello.
Good
Hello.
Hello. So I'm going to be doing the experiment or the activity, which is a bit more this week. So first, it wants us to discuss what we know, discuss what sedimentary rocks are, what do they look like, and how they are formed. So this is our engage phase of our activity.
Mhm.
So I believe that sedimentary rocks are formed from the movement of water.
Yeah.
Does anybody have, or I
uh,
guess the effects of the weather?
Yeah, like wind or like erosion or something like that, like it forming like layers of different rocks on top of each other or something like that. That's my basic knowledge on the subject.
Yeah, I think
I think of like the cliffs, like if you look at a cliff and seeing the different colors and the different levels of a cliff, and you can see it's different kind of how old it is.
Yeah, and I think that's caused by weathering and erosion, just by constant wind and rainfall, slowly moving the big pieces of rock into small pieces, breaking it down, causing sedimentary rocks to form.
do we include the biotic? So the skeletons, plant life, that's included. That was my understanding, at least. Like sedimentary is just the big, massive combination of all the different rock types and just any other bits of organic or whatever, all compressed and weathered over time.
Yeah.
Wow.
Right.
So in front of me, I'm going to flip on my. So in front of me, I have 3 different samples of rocks. So these orange ones are small rocks that they have called pebbles. We have some little flaky rocks in the red, which is from erosion. So the effects of the wind and what that might have on the Earth's surface. And then the third one is the mud type rocks, which is the effect of water on the soil at the bottom of a river. So it says, discuss what the term pebbles actually means. Anybody have a thought about what pebbles actually are?
So I think in the last tutorial we looked at the sort of rock, I like to refer to it as like the rock hierarchy, how it went from mountains and then mountains to boulders, boulders to rock, stone, and then stone into, I think it was smaller stones and then pebbles. And I think pebbles were broken off of larger rocks from water erosion. That's why they're sort of smooth and round, because the water's sort of like smooth them out over time.
Yeah, that was my thought about the water and the effects that the water might have on them. That's why they're smooth, because if you think of, the pebbles at the bottom of a river or the bottom of a creek, they're always very smooth.
Yeah,
that's because they got constant water pressure on them as well over that time. Wouldn't it?
So the next question is about the effects of the wind on the Earth's surface. And it says, discuss what name is given to this process and how you might represent it with Play-Doh. So I've gone ahead and called that a bit of a wind erosion, and that it would flake off little bits of rock, clay, whatever it needs to be. Does everybody agree with that?
Sorry? What was it called?
So they've called it erosion. So the eroded sediment.
Okay.
Like broken down pieces of rock.
Pretty much.
Mhm.
That's a nice way to put it. And then our third is the soil at the bottom of a river, which is affected by the water, which often is moved by water in layers. Discuss the name given to this process and how this might be represented in Plato. So this is where I have thought that mud and clay would form.
Mm.
So I've created a mud sample.
Yep.
So I think that would we also say that's a lot because of the water cycle and everything and changing pressures along rivers, creeks, and in the ocean, even if we're just going along that way.
Yeah, absolutely.
Just like because if you're saying different layers and everything, like that's sediment, that's a bit of sediment because you're getting all the different layers of sand, silt, and other rock just all flowing through water at different spots, and then over time it just gets whittled down and everything like you were saying with the erosion before. It's essentially water's version of breaking down a rock into flecks and different fragments and everything.
Yeah, absolutely. Anybody else have a thought? All right, so I'll move on to conducting the activity. So it says place an open, empty Ziploc bag, which I have here, into a cup and place the rocks, erosion and mud into the empty bag. Use all the Play-Doh and randomly add the colours. This process represents the movement and disposition of rock materials in the natural environment. So I can just deposit, the materials in any order.
So are all the materials, like all of that, the mud, all the pebbles and all the erosion going into that one bag, or is there another bag that it goes into as well?
No, so they're all going into the one bag, and then eventually I will take 2 different samples of this one, and then we'll do the water experiment next, and do some more core samples with that. So I believe all of this is going into there.
Awesome.
Easy.
Do we think there's a reason why it would be going in a random order?
I think it's to represent all of these coming together
And it would
at
be
different points.
well, you're saying it was a natural process. Well, trying to replicate a natural process, so you can't really pick and choose in nature. It just happens. So I think
Yeah.
that's a good
Yeah.
representation there.
So I'm
It's-
trying to keep these as informed as I can.
Without squishing them together.
Pebbles rolling off.
Ah,
He's seen what's happening to his friends. He's leaving.
I'm not going in there. So it says discuss what you might find if you pressed everything in the Ziploc bag together.
Just a amalgamation of color, I guess.
Yeah, I don't know.
I feel like the
Well, might join together.
pardon.
They might all join together. I find maybe like they all clump together. If you're gonna, are you gonna shake it? Pressure.
No, so I'm going to press down to
Oh,
apply
okay.
pressure.
Okay, yeah.
But I won't squash it flat.
Okay, but they'll still kind of have their own form still, like they'll still contain their own kind of form of what they were, but then just all squished together really.
Well, I think one of the points will be that when we look at the core sample, the pebbles will hold their shape,
Mm.
and the red or the pink won't be as evident, which was the flakes, because I believe that they eventually over time will probably become one with either pebbles and form into a pebble or become one with the mud.
Oh, okay. So after time, everything just becomes one essentially.
I think so. That was I guess the initial hypothesis with this.
Mm.
Is what we're going to see when I take some samples.
What is the initial hypothesis?
Yeah, do we want to state that using the
Before,
if then because?
Yeah. Before we see you smash the colours all together, let's kind of get an idea of what we're thinking.
Yes. So what do we think we're going to see in the first sample? So I'm going to, in a moment, is squash these, press these down a bit, and then I'm going to take a core sample,
Mm-hmm.
and we're going to document and describe what we see and look for patterns in what we're seeing. So
if we compress the different sediments in the plastic bag, we will then see that the pebbles will retain their shape while the other ones sort of mash together because they don't have a structure. They don't have much structure, I guess.
Mm-hmm.
Okay.
yeah, that was well said. Yeah,
Yeah.
yeah,
good.
I like that. I think that was concise, like did well at putting what we had talked about into a nice concise sentence.
It wasn't
Okay,
very
so-
scientific, but
Well, it's only supposed to be an inference and our observation, and then our final hypothesis will be linking what our observations to it to our final. Okay. All right, so I'm going to squish it, but not flatten it. So it says use a cube-shaped mallet. So I've just used a nail polish bottle,
Very nice.
not my nail polish bottle. Let me just.
Yeah, good colour.
My son thinks. So that I have squished it down a little bit, applied some pressure, tried to put even pressure throughout the bag. All right, now I'm going to open the bag and take 2 core samples.
Looking, I think what Darcy was saying earlier, it's looking like the pebbles have retained its shape even now as you were just pulling it out.
All right, so
flakes are still hanging on there.
Mm.
So I've just used, instead of a clear plastic straw, because they were quite hard to come across in this age of getting rid of single-use plastic. So I have used just plastic shot glasses. So I'm going to take a similar sample for both bits.
It looks so satisfying, that Play-Doh.
Does it say from what angle you should take the sample? Like, does it say like a little?
From top through to the bottom. And then it says choose another place to sample and do this a second time with another.
Oh, so it's just a core sample anyway.
Yeah.
Anyway on the piece.
So you can see why here the straws would be helpful, because you would be able to use exactly the exactly same amount in both samples.
Mm.
Whereas I have used my eye in having those as close to the same amount as I could.
Mm.
Well, that's.
So sorry.
I was just going to say, well, that's something we can discuss later on about how we'd run the experiment properly, or how we change it or add.
How our pedagogy might be different.
Yeah.
And especially that going forward. So if we did this with the class in 12 months' time, we wouldn't be able to find single-use plastic straws because they're going to be banned. So that might be a point for us to talk about a little bit later.
Yeah.
So it says document and describe your observations in the 2 samples. Look at the patterns.
Had to zoom it in.
What are you seeing?
The pebbles still kind of contain their shape, like on the left one. Like they're still quite big. The blue's all mushed in. I can't really see too much of the red.
Yeah,
On
it's
the
like blue has lost its shape.
Do we?
in
Blue
the
has a
example, you can sort of see the flakes of the ready pink through there.
Yeah. It looks
but I'm
like
not sure who said it, but you're definitely right. In the blue has completely lost its shape in both. But
Yeah,
you
it's
can
just
definitely see in the first that the pebbles have kept their shape very well.
Definitely.
I find because the pebbles have kept their shape very well is because during that process of you squeezing and combination of pressure, it takes it a lot harder for a bigger object to break down because it's quite a solid.
The other
Yeah.
ones
Where,
were in
yeah, where the clayey mud is not so thick and solid. So
So-
it's a lot thinner. So
And
it's
have
easier to
shape
break
to
down.
start with. Yeah.
Yeah.
I think that's right there. 'Cause-
Excellent.
oh, sorry.
No, you keep going. That's fine.
Well, I was just going to say, like, you can see that the mud, as Kira was saying, is the mud or the blue really just didn't have anything structurally to it, whereas the pebbles were more condensed and it was like very solid core thing. So I would be surprised if the pebbles were crushed a bit. But I mean, you can see it if we look at the right side. Yeah, that one there. If you look at the bottom, there are flecks of yellow and somewhat bit of pebble there that have been squished a little bit. So I think there's definitely the reason to say that compared to the other one where it's completely intact, left side.
Okay.
Yeah.
Do you think that has something to do with the fact that this had the two other forms of rock on top of it, whereas this had just the pressure?
Yeah,
So
exactly.
say if that pressure was coming just from water, whether it changes because there was other types of rock on top.
Yeah, I think that would definitely be that's a factor there because well, if we were talking as we were saying about weathering and erosion and everything before, it's you're taking away and you're applying pressure, heat or cool,
Yeah.
get the movement and the change. But if you've got the two as on the right side, you've got the extra sets of material on top of it. You're not got to really have much of a impact when you apply pressure. It will be more of the pressure from the other two materials that are on it. So you're getting, what would it be? Like 3 times the pressure, 2 times the pressure? I think that'd be something along those lines when affecting that pebble compared to the left side, which is you've got the two on top and they still look pretty solid and pretty good because they only got the one form of pressure or one form of weathering.
Yeah, and it
Yeah,
depends
the side has
on
a
where
big impact.
and where you took the sample from as well. Like it's going to be different from wherever sample you take it from. That's why they're so different.
Yeah, I think so. So we've got some questions to think about, and we've definitely talked about the first two, which were how are the samples different and how are they the same? And then it said, how does the sample reflect the way the rocks were made, which I think we've talked about as well. And then it says, how could you determine if a sample was a sedimentary rock sample?
I guess the distinctive layers that you could see, like in the samples, like if you could see each layer clearly. So if you flip it on its side like that, yeah, you can see sort of how it has the different layer, how it goes from the pebble to the mud and then other layer.
Mm.
Yes, that's what I was thinking too, is the different kind of forms of rock that you can see. And
Yeah.
even though they have, I guess, squished together, they haven't blended colour. So they've still kept their own rock.
Yeah, it's like they've all collided.
Yeah. So they're
like-
kind of sitting next to each other, but they haven't merged into the one thing. So they haven't created like a green or anything like that from forming the colours. If that makes sense. So it's like, I think that's similar to seeing the distinct layers, is you'd see the distinct rock types.
Yeah.
Awesome. So we're going to move to activity 2, if everybody is okay with that.
Yep.
So it says, discuss what a metamorphic rocks, what they are, what do they look like, and how are they formed? Metamorphic. Sorry, I don't have my glasses on. Metamorphic rocks. So in this experiment, to give us a clue, in this experiment, we'll be putting our sample into hot water.
Well, I think metamorphic ones they're changed by their heat and pressure, and they're like combinations of other rock types and everything, or other distinct rocks or individual rocks that have been kind of molded together with heat and pressure. I believe it's underground over time, something along those lines.
Yeah, with other existing rocks around it.
Yeah.
Basically it.
Now.
Yeah, so metamorphic rocks are found deeper underneath the Earth's surface. Instead of it being closer, it's more deeper.
Okay.
Yeah.
Why do we think they're found deeper rather than higher on the surface?
There's more heat underground, isn't there?
Yeah.
Yeah.
And the
That
pressure
was-
as well, like with other layers on top. So
It's closer to the tectonic plates. So like where the inner core sits in the Earth's surface. So you find a lot more heat that circulates around there.
mm,
Absolutely. So before we start this experiment, so we are going to be putting our sample into some hot water. So we need to discuss the health and safety aspects around this. So what it's got some kind of talking points here for us with this. Does anybody want to shoot out some health and safety before we go into the points?
Yeah, definitely.
Oh,
Definitely wouldn't be trusting children with hot water.
yeah.
I feel like that's more of a teacher, the teacher can do the hot water activity while the students do the observation.
yeah.
And not even, so it says about 60 degrees, so it's not boiling water. So you don't even think for like grade 6, 7 students?
Like
Potentially.
Did we establish what grade we were doing for this?
Yeah, what's the aim?
What grade did we think?
I think this was more of a 3 or 4.
Yeah.
Yeah, I went kind of grade 3.
Looking at because
Yeah.
I remember rock cycles and Earth and Space, grade 3 was
Yeah.
really one of the big times where you got introduced to the more like distinct terms and everything, and like geology and everything. I could be wrong.
No, I agree.
No, I think you're right, because they're like playing with Play-Doh. Like if they're like a higher grade, they'll more focus on the natural process of a rock.
Yeah.
Yeah.
They'd be
So they
doing
fun
that.
and engaging.
Yeah, I was thinking grade 3 as well.
Okay.
Yeah.
So
Yeah.
it says, because in this experiment that they've given us the example of, the students actually do it. Because our talking points are, what instructions should students know about transitioning to and from the water bar? And should students use their hands or hold the bags, to hold the bag, or wooden tongs?
Oh, so we'll be using a water bath with this one.
Yeah. So yes. So when we're ready, I will fill up a cup with some hot water that I've got in my nice little Sharky thermos, and then we'll be placing the bag in there.
Okay.
So
Yeah.
I think
Safe. Yeah.
Sorry, you go.
I
Oh,
think
I
if
think fine. Yeah.
I think
Go
if the students are doing this, if we kind of look at it from that angle, just because on the sheet the students do it, I think as a teacher it would be really important to gauge whether your students had the ability to do this safely or not. So if they're a really rambunctious class, that might not be the smartest idea, or maybe once the students get to this point of the activity, they need to come up to the students, to the teacher's desk, and the teacher has the hot water there and monitors it that closely, rather than giving them hot water at their workstation.
I think too, if we're using water baths and everything, there's definitely the health and safety risk of them putting their hands in by accident or having the extra spill come off. Because if I remember correctly, water baths are a bit like deep fryers and everything, where you've got the little boiler sections and you actually have to pull out.
Yeah. So on our activity, it actually shows exactly what you're talking about, I believe.
Oh wow.
Mm.
Yeah.
And like the teacher could even place that just before they start the activity, so that sitting there on the bench with them sitting around, making
Yeah.
it tempting for them to play with, the teacher could bring it out as soon as they start the activity. Like when she's discussing it, bring it after, not before. Stop the kids from mucking
Oh.
around with it.
I think it too still comes back to what Darcy said, which is probably the best way to do this, especially with a smaller class, is for you to do it and them to observe.
Yeah.
If I add something, it depends. It depends though, because say for the first activity, the students could obviously go hands-on with it because they're only applying a small amount of pressure and there's no heat involved.
Yeah.
But the thing is, you've got to explain to students that they're not flattening it, and you can have particularly boy students who want to like punch the Play-Doh and get it as flat as they can. And then we could also go, oh, okay, well, some of the students wash the dishes up at home, so they might have gloves that they can use for hot water. But then again, you run into that same sort of issue where you don't know whether you want them to sort of taint the experiment by taking it too far and squishing it as hard as they possibly can, opening the bag or whatnot.
Yeah, I think that's a really good point, because I mean, if you that'll come under human error and any like individual groups and everything, wouldn't it? Like with the pressure, the difference in pressure, and that would result in different results. And I think you do the big class like comparison, or like everyone puts up their results, see what it'll be like, just to mitigate that.
You could do a class experiment, like a whole class sort of run through the experiment first, and then you could get them to maybe explore it in small groups of say 5 or 6, with each student having a specific role.
Yeah.
Or you could even do it too, similar to that, doing it all together, but with like a large sample size. So and each student gets their own little straw, and they get to come and place it and get themselves the core sample out, and then take that back to their desk and write their observations and things on it before then coming back to discuss it.
Sounds like the way.
I like
And that will control the behavior management too in the classroom.
Yeah.
Just because kids, when it comes to like hands-on activity, if they're all go split out into their groups, and we're talking grade 3, they're all just going to go wild and crazy and excitement and that. So I feel like it's teacher to have more control in that state, control behavior.
Yeah, definitely.
Just coming back.
Be a set of rules or something already put in place, and like have those distinct. These are my expectations. These are boundaries, exactly.
Yeah.
Just coming back to that straw idea that you had, I think that's a really great idea, because then you'd have students who are really excited to learn about this, and they'll be comparing with other students what levels they got in their core sample and what different colors they can see in there. So I think that's a really good idea.
I think it helps to mediate that pressure concern we had before too, about kids coming in and demolishing their sample. Whereas if we have one kind of group sample everybody, has that same amount of pressure applied.
Because you could do it with a bigger bag, but the same, like in a more quantity. So each class could have like one big bag that they can all take their samples from.
Yeah. And I think the students would really enjoy that part of it, because they actually get to collect their own core sample, just, as they did if they were doing this as an adult.
Yeah.
And things like that. So moving on to this experiment with the water, what temperature should you use in a primary school to ensure that it is still a low risk activity?
I think 60 is too high, because when you think about it, spa baths only run at 40 degrees and they're usually pretty hot. So I'd say even like 30 degrees, because you've still got that heat there, but it's just a little bit less hot.
Mm.
30
Yeah, I was thinking about the 40 because
Yeah.
I think the 60 is a bit high, especially with little hands. I think that the tongs are a good idea. So if they're doing the actual water bath, having the water bath next to the teacher, but having the students be able to do it holding the bag with some tongs or something away from them, so that if there is splash back or anything like that, it's hitting the tongs and not the student. And even somebody popped up before and said about having gloves, so like the dishwashing gloves,
That
which
just
would help.
extra bit of PPE.
Yeah.
Any splashback or anything. And I think I agree. I agree that we're definitely somewhere between I'll probably say just a little bit less, like 25, between 25 and 30. Yeah, because if it's meant to be a low risk activity,
Mm.
you can still get low burns from like water burns and everything from 30 degrees. So
But it's weighing out too if that's going to be hot enough to have any effect on
Yeah.
the Play-Doh.
I would say 30
wonder,
to 35.
30 to 35.
Yeah.
I
'Cause you
wonder
still
if
can't
they're
quite-
using their hands to mold it. The heat generated from their hands as well might have an effect, but that also depends on whether we let them use
Yeah.
their hands for it.
That's true. All right. Well, I guess
Okay, so and then just finally it says, what else should be discussed with the students around behaviour management associated with this activity?
well, I think we did that one before.
I'll do that.
Do the rules and have the expectations, as Kira was saying before, and so was Maddie. Sorry.
No touching the products while like the teacher's explaining as well, because not having it in front of them until we're doing the experiment. Otherwise they'll just want
Yeah.
to play with it and touch it.
So things like as well having what to do about spills, and especially if it's a big spill on the floor, having that freeze protocol, so everybody freeze.
Yeah.
You know, just because if for some reason, you know, this water bath got tipped over, you'd need something in place to get the students to stop where they are straight away.
Yeah.
Coming back to the whole safety thing as well, the don't eat it, drink it, use it as a weapon. And that goes for all of the materials used. The tongs, even using those to like poke or prod other students.
Even the Play-Doh, don't throw it at
Yeah.
each other. Just don't
Yeah.
do it.
Yeah.
I remember in my prac course we did, we were doing 3D shapes, and they got to make 3D shapes with their Play-Doh, and year threes can use Play-Doh as a weapon. I discovered that day. Okay, so record. So we'll have a look back at this, at what our sample looks like. I'll show you before we put it in the water. So this is our leftover. I've left the other two core ones in case we need to revert back to them. But this is the rest of the Play-Doh still squished as it was before. So we can still see the pebble kind of shapes in there. And we can see that all of those observations we made before are still being shown in this. And so I'm going to put some water in our...
Sorry, can we just pause it for a sec?
Yeah, absolutely.
You can do it. Let's go.
Yeah.
All right, so I'm adding our hot water.
Darcy's on the timer.
Yeah, got timer all ready to go for 2 minutes.
And then, so this is going to sit in our water bath for 2 minutes. Do we want to make some predictions here about what is going to happen?
I think that'd be good. Yeah.
So mine is that the mud is definitely going to start, I guess, conforming around the other shapes. I'm not sure how much the pebbles will lose their shape. I think it's going to be similar to the pressure where, because those pebbles have such a solid shape to begin with, will hold their shape a bit more.
How
Yeah.
hot is it again?
It's about 60 degrees, this one.
So we need to take into note that the results may be different if we're doing this in a classroom because it's a lot hotter compared, like we're halving the heat. If we're doing, say, 25 to 30 degrees in the classroom, it might take longer for results. Like, would we expand the timer or would we just keep it the same as what we're doing now?
I think expanding the time might be a way to mitigate, just compensate for the less heat.
Yeah, I agree.
So do like 2.5 minute intervals or 3 minute intervals or even 5 minute, do 2 5-minute intervals.
Yeah,
Mm.
For 10 minutes.
10. Yeah,
Yeah.
I think that would be the way to go. I also think like just a prediction for this one. I think any lighter material or any of that material with any less structural integrity definitely start molding or mixing in with the others. Like there will be a mixing impacting effect. I think we're talking about with the just the definition of metamorphic rocks and everything. I think there will be a combination event happening, or just a solidifying event. Oh, and we got the 2 minutes.
2 minutes done.
Excellent. All right. So I am going to, oh, no, not yet. I'm going to move the bag backwards and forwards or side and side so the hot water flows around it. So I'm going to go side to side, making sure I keep it submerged too. And then I'm going to remove it and squish it as much as I can. It says really get into the squeezing part.
I was going to say, just taking that bag out, you can already see that the colours are starting to run into each other.
Yeah.
Yeah.
So just even before squeezing it,
Yeah.
especially that blue and reddy pink.
Yeah, the blue.
colour.
Blue. It's having a nightmare.
Please
Mhm.
get away.
All right, I'm going to give it a squeeze. Squeeze.
With this bit, like what, depending on the size groups we have, like in the classroom, kids might be like, oh, I want to do this. No. And, you know, they might fight over like who wants to squish the Play-Doh.
Well,
so
it
like,
does. Sorry, we do have to repeat it a few times until 10 minutes
Okay.
is up. So it
All right.
may just be taking turns.
yeah, so maybe
So it-
going around the group.
But would that
Yeah.
change the effects if we did different people each time? Because I mean, like we were talking about grip strength and pounding it earlier, with when we're applying pressure, like different students and different children would have different levels of strength. So would
That is
that
a factor.
be a
Yeah,
factor?
absolutely.
We can still, it would still be a good process, like give everyone a chance to do it, but would that be a contributed to results varying and like a thing? Because if you've got a young boy or something who happens to have a lot of grip strength, and then a young girl who has a lot of grip strength, their two results will be very different to a boy who's a bit weaker or a girl who's a bit weaker.
Yeah. But I guess
Yeah.
that taking turns in groups would sort of
Yeah, kind of compensate for it, wouldn't it?
blend it out a bit. Yeah.
You kind of have to spread it around, really.
Yeah.
Yeah.
So we've got a basic concept of what's happening. Kira, did you want to go over the current dominant understanding of what would be happening in this process?
Sorry, Duffy, are you still timing?
Yes, I'm timing now. You threw that one in. It's a minute now.
Okay, excellent. Sorry.
No, you're good.
So are we talking about the CDSU now?
Yeah. We'll being time conscious.
You're
Okay,
going.
just-
same.
We have a few minutes left. Well, so as you can see in there, the clear in-depth understanding I've gathered is that metamorphic rocks, they start as one type of rock, and with pressure, heat, and time, the existing rock must be exposed to heat and high pressure. So these are found either deep in Earth's crust or around the tectonic plates colliding. So obviously the pressure you're doing when squeezing, obviously the collision of plates and like around that rock, because the tectonic plates are obviously moving, that rock is just moving around.
2
2
minutes.
minutes.
Yeah, so if there's too much heat and pressure, obviously the rock will melt, it's saying, cause and become magma.
Okay.
So we
Yeah,
should
so-
be seeing that in the experiment.
Pardon?
I said just so we should be seeing that in the experiment, what we're seeing now, how it's
Yeah.
sort of all becoming one. I guess you could say magma-like in how, because I think it explains, like I think one of the questions asks what it's feeling like. Could you give us a
So
example
it's
of?
definitely not as resistant to squeeze.
Yeah.
It's getting less and less, becoming a lot more.
Malleable.
Pardon?
Malleable.
Is it
Yeah.
melted or is it all completely just lost its shape? Like, is it like, what does it feel like?
It is still having a little bit of resistance, so it's not completely melted.
Yeah.
It's just completely losing a lot of its shape.
Because if this melted, for instance, if we had like 1,200 degrees Celsius of magma, that would turn into like an igneous rock. So it would turn to another form of rock after that process that's happened. If we had too much heat and pressure focused on that rock there. So yeah, just a little bit of information.
Very nice. Mm-hmm.
Slide it in there, just credits.
The third time the bag's gone into the water now. We're at 30 seconds of it being in there already. Can you feel any of the defined shapes of the pebbles anymore, or?
You could still a little bit, especially in the middle, could still feel a little bit, not so much the shape, but just a little bit more resistance
Yeah.
against them. So they've completely lost their round shape. They're not a sphere anymore.
We say
But you can squeeze through the red bits the easiest. I'm trying to use observational language, not scientific. So squeeze through the red bits the easiest, and through the yellow bits a little bit more resistant.
And has blue just molded with everything?
Yeah, pretty much.
We've got to take photos of all of the samples, don't we?
Yeah.
Yeah, so just
Yeah. I can, if need be, I can go through and just do screenshots in the recording just to get them, because we did show them up to the cameras as well, and we've actually been able to get a good look at them. So I can go through and get screenshots as well if we haven't already got some photos, or if Lana can't get any photos of the water fella.
I think
It might be worth doing. Pardon?
Oh, sorry. I was going to say, I think it would be really good if Alana shows off all of the samples in a row at the end, and then we just get one big screenshot of that.
Okay. No worries.
That's 2 minutes now again, by the way.
I think definitely putting them up against each other at the end will be good, because we need to discuss the difference between a sedimentary rock and a metamorphic rock.
Yeah.
So I'm noticing a really big change this time in it's very gooey. So it doesn't feel like Play-Doh anymore at all. It just feels like more of like a gel-like, if I was squeezing a bag of gel, or like icing.
Yeah.
So if you've ever iced a cake, it kind of feels like icing.
We can
Yeah.
still see those colors, though, separated sort of.
They
Yes.
are starting to become a little bit green in
Yeah.
places. So we're starting to get some green out of some color mix, but we've definitely still got that big orange presence.
That'll be fun getting a sample of that.
Be great. All right, shall we do one more to make it up to the 10? Is that one more? Yeah. Let's do
Go
one
on
more.
and I mean, technically it's only 8 minutes, but with all the squeezing and stuff like that, I'd say it says complete this process for 10 minutes. So I'd say with all the squeezing and that, it would equal about 10 minutes.
Minutes altogether. So it asks us, why do we do this a few times? So why didn't we just do it once for the 2 minutes? Why have we done it over and over again?
To get an accurate result.
And I think,
But
yeah.
Like the more time. Oh, you go.
Oh, I was just going to say, like, get a bit of an accurate result, because we're trying to reflect a natural process. So there isn't any like limit on how much time can pass or anything when it's happening. So the more time we get the chances to squeeze or apply the pressure and the heat, it's more linking back to that natural process.
Yeah, we can understand what the real process would be like. Because if it was only, it's not realistic if it's only happened once.
Yeah.
And then we can go through the phases and see, like at the first phase, it was still pretty resistant, but then towards the last phase, it had completely transformed basically.
Mm-hmm.
So it's important for kids to understand that process.
Yeah.
Do we want to talk about how we might graph this data?
Yeah.
My initial thoughts were maybe something over time, so we can see how through the lengthening of the process, how it's changed over time for the metamorphic.
Mhm.
Yeah, I like that. I think you could do like we were talking about before with the images, show a process image, like a process image graph. That would be the way to go, because it just gives that bit more of a clearer, and we can just make we've already made the observation, like how much resistance was there.
Is it worth then making an observation, like a table, doing a table up at 2 minutes, 4 minutes, 6 minutes, 8 minutes?
Yeah.
And
Alana, it's time.
is that 2?
Yeah. Sorry.
Yeah, I think that would be the way, and just using the images and just putting that percentage type of track going along with it, all the time track as well.
Yeah. Because for the graphing, it doesn't have to be a specific. It says pi, bar, or line, doesn't it?
Well, line graph, line graph, like time going up and percentage on the
Percentage of what though?
I'd say resistance.
Resistance. Like how mushy it's getting.
Yeah, because I mean,
And
if
then,
oh, sorry.
So I just wanted to point out about our colours in this. That it has all started completely forming into, I guess, one, and really, really meshing the lines of what they are. You wouldn't be able to look at this and tell me what shapes they started with.
Yeah.
Whereas when we went back to this one, you can tell that the orange started as a circle.
Yeah.
Whereas this, you definitely couldn't.
Mm-hmm.
So I'm going to go ahead and take some samples.
Sorry to rush this, but do we have our final hypothesis?
Yeah.
I guess we'll have our final after we scoop this out.
Yeah.
Comparison. We are being sort of time conscious, but
Got that. Ooh.
So I'm trying to get this sample out without
can you
changing
scoop?
the shape.
Yeah.
Yeah.
Um,
If you had a spare glass. Oh. Oops.
staying there.
Doesn't look pleasant, does it?
Oh.
It doesn't feel pleasant. I'm just going to
I think Kira said it best earlier, nightmare fuel. Right there.
It's just brownie mix. That's all it is.
Oh.
I thought it would have been more liquidy in a way.
It definitely yeah, not as liquidy as I thought it was going to be. And then it do it like this. So I'm just going to present these to you all together
Yeah.
so we can see this and have a little bit of a chat about the difference between the first set of core samples and the second. Just stay there, little man. Yeah, it's not a fun
Doesn't it look
feeling.
names that's left on that paper? It doesn't look fun.
Should see my hand. All right. So the two on the right are from our first one for the sedimentary rock. They were our two core samples from the start. And then the two on the left are from our metamorphic rock.
Okay. Well, you can definitely, it's first of all, you can see that there's 3 distinct colors and forms in the right-hand side with the sedimentary, and then left-hand side, it's one, almost practically one color in one form. That's the observations I'm making from that almost immediately.
Yeah, definitely the form. You can still see even the shapes in
Yeah.
the first two, even though they had less pressure applied, you can still see. Whereas the second, you
Yes.
can't.
So using our final hypothesis, to make our final hypothesis, it's observations plus inferences.
Yeah, so it says write your final hypothesis. Your final hypothesis by linking your inference with your observation.
Kira, did you want to add something there for the final hypothesis?
Yeah, so I was thinking, so our initial one, what was our initial one again? Just a repeat of that one, sorry, just so I can remember what the...
So I think it was like if heat and pressure is added to the sedimentary rock, it would then turn into the metamorphic rock, or like the colors would start to blend together because of the heat and pressure or something that was added.
Yeah.
So was our initial hypothesis correct?
I believe
Yes.
so. Yeah.
In a way, yeah.
Pretty accurate.
I mean,
Yeah, I feel like it's...
yeah. Well, the right side.
If-
Sediment. Oh, sorry, Kira. You go. My bad.
Oh, that's okay. No, like if we added heat and pressure into sedimentary rocks, then we will see
A change in
metamorphic rock appear from the collision of all different rocks. I don't know, like something along those lines. It's like exactly like our initial hypothesis. We didn't really have to change the hypothesis. Yeah, because we've seen the result there. Caused by heat and pressures cause metamorphic rock to appear, and yeah.
So as
Does anyone else-
It molded over
statement.
time. It
Yeah.
molded in metamorphic rock over time.
Yeah.
Yeah.
Big.
Good.
All right.
I just have one
What else?
last question before we finish the actual experiment. And it just says, do you think you could now identify a sedimentary or a metamorphic rock sample? So if you were presented with one of these samples, would you be more confident in saying, well, I think this is a sedimentary rock, or I think this is a more metamorphic rock?
I think
Yes.
so.
Yeah, I would.
Like in a metamorphic rock, you'd be able to see, like, as you can see now, like from the Play-Doh example, like there's a mix of, you can still see a slight mix of colors where they've kind of molded together, whereas at the beginning they were very set in their own color, in their own shape. Yeah.
I agree.
Basically just through observation, really. Yeah. Like it's pretty obvious.
Yeah.
Yeah, definitely.
Mm.
Yeah.
Okay, so I think that concludes our experiment.
I believe we've been talking through some of the CDSU stuff as we've been going through the experiment, a lot of the health and safety as well.
Yeah.
What?
The only thing thing that we didn't cover was alternate conception. So maybe how students will perceive it.
Yeah, that was another.
Yeah.
So I was about to say, the theories and the conceptions behind it, like what underpins all this thinking and why.
Yeah.
And I think that just comes down to understanding the rock cycle and understanding that natural processes like weathering and erosion can occur, and their effects aren't immediate. There is a time factor in there, and this, like we use the smoothness of rocks in a river before, pebbles in a river. That happens over time because you've got constant water pressure applied, and the different materials are rushing over it, and that's just weathering it down until you get that soft or rounded edge on the material. So I think having students understand that there is a difference between different rock types. There are differences in how weathering or erosion can occur, and that in different environments, different effects can happen. So like as we said before, with the underground constant pressure and heat, we can get magma or igneous rock, whereas like in river we can get more sedimentary, and I don't think metamorphic would be there unless say like a volcanic
I
spring.
think you lose the heat element
Yeah.
in that.
Yeah. Exactly.
So,
And I feel like for kids' deeper understanding, we could actually refer to real life situations so they have a deeper understanding of why this is caused, like sedimentary rocks. Like they'll think, what is sedimentary rocks? Like after this experiment, they might get a bit confused on what it might be. So we could like include maybe the Grand Canyon. Why has it shaped like that over a long, long period of time? Why has that rock curved in that shape? And the Himalayas, just all that type of stuff caused by wind and rain. Kids will then refer to that and go, oh, okay, I can see what they mean now. This is caused by weathering, causing it to go to sedimentary into metamorphic or whatever it can be. But I think good examples like the Grand Canyon for kids to have a deeper understanding of the concept.
it's
Do
definitely
you think then maybe that would be in the next couple of lessons, is presenting them with a different samples of rock or pictures or physical rocks and getting them to list what they're observing and get, I guess, from their observations, choosing which kind of rock it is?
Mm.
Yeah.
all right.
Okay.
And I know we have to kind of discuss about diversity and that with kids too. I just trying to deal with the time.
No, that's all right.
But yeah.
Well, I think that's
trying
the
to think.
first is just what we talked about earlier, like having those group setups, like heterogeneous groups set up, and you have a bit of an idea of your class ability already. That means you can cater for it, as we were saying, like with gloves, or set of rules, or just methods and everything in the classroom. Because if you've got a rowdy class, it's not necessarily got to be a thing that you go individuals or group work or driven. If you've got more of a responsible class, group work, perfect. If you have students who require any additional needs or support, well, you can set up your groups in that way. So you have students who are a bit more switched on will be able to help with peer mentoring or peer collaboration and everything.
Yeah, I agree with
Even
that.
even if you did it in,
Sorry, you go.
you're right. If you did the groups in a different way, if you think there's going to be quite low level students who will need a lot of your support, having them grouped together might also help too, because then those expert ones can just be given the activity and go, whereas you could do it in that way as well, so that you can kind of focus your attention a little bit on the groups that need a little bit more support
And give them that bit of
For
one.
example, like a kid with ADHD, like I think having the heterogeneous groups would be good, because if the lower ability, they're just going to get distracted, and the kids that can't really support them, say if you put a kid with ADHD with someone that knows what they're doing and that's sensible, that's a bit of more of a high achiever, they can help that student keep in line a bit, because that kid will just want to keep playing with the Play-Doh or do something like that, whether it's if they've got, someone that they can kind of not look up to, but that will keep them in line a bit. I think that's important.
So really being smart about your pairing or your grouping.
Yeah.
Knowing your
I think
students.
like
The best way to
planning
cater
your
for a
groups
diverse student
before.
is knowing them. Yeah.
Yeah. As
Just-
long as the groups are planned.
sorry. Just
Okay, I'm going to head off, but you guys can keep chatting on the group chat. You need to talk about
We're
anything
done.
else.
Yeah, we are. I think it was just the nature. That was just
Okay.
like, natural disaster, why it happens. So we got that.
All right.
Okay, sweet. Sorry, it's just work. I'm like, ah.
All good. Bye.
Okay, see you guys. Thank you.
See ya.
How do I get out of here?
Ah, she's gone.
Should we end the recording?
Covered.
Or do we-
Covered everything. Addressed it all.
Yeah.
Just wanted to add
Definitely.
one thing with the ADHD statement. I think because it is a hands-on activity, they will be more engaged and inclined to actually want to learn in this.
Oh,
in the
definitely.
curriculum. So I feel like that's
Yeah,
a good.
definitely.
You could take that one step further as well and just say, like, if we're doing group roles as well, what we said earlier, you can kind of direct a group role to a student that you feel best fits that role in a group. Like, I know that's might come under a bit of bias or anything, but if you're trying to support learning and everything and get an engagement, like, you try and group students in a way that will promote engagement. As Darcy said earlier, like an ADHD child will like more hands-on. And so if you actually get to, say, for example, like thinking or like the rolling out of the different materials, I think that would be
Yeah, absolutely.
Yeah, group roles are good.
all right.
Do we need to discuss the left-hand side on the recording?
I believe that's the document we submit.
Pardon?
I don't think so.
No, I don't believe so. That's all our learning, like solidifying everything. And
Okay, cool.
If you want, we
Stop
can
the recording.
go over what we learned as like a summarizing statement.
right now,
Well, that
Yeah.
might be a good way to go to end the video anyway.
we'll end
Yeah.
it. All right. So, what did we learn, everybody?
I guess.
So for me, sorry,
No, you're
Um,
good.
it's so hard doing the
I
virtual one.
know.
So hard.
Uh,
For me, I think I learned a lot about the metamorphic rock, and how even though we applied pressure to both the samples, both the our first activity in our sedimentary rocks and our second activity, how adding the heat really changed the effect.
yeah.
If that makes sense, how much of an effect that had on the second round.
It's different to see it in practice. Like, it's all good to read about it, but seeing it in practice is definitely
Mm,
one. And I think I'd
definitely.
agree with that one. Just having a look at actually seeing it happen in practice and getting that bit more of a hands-on look at it, and you see, like, just seeing it change. Like, I mean, we noted the color change and different variations, but that's just a good visual tool. But I mean, having a look at it all just come together. That was
I just have a point to make about because if we were saying that we would do the heat maybe at like 25 to 30 degrees for kids and making the time longer, like being time conscious of the actual activity, like we don't have an endless
Yeah.
timer on the lesson, so I feel like
That's why I said
how
sort of.
would we find that balance?
That's why I said either two
Yeah.
5-minute intervals. That way you still got that 10 minutes, and they're using their hands as well
Oh,
to
okay.
mush it up. Either that or
Yeah.
another different interval.
Yeah.
Because if we
Could we
attend-
add a heat barrier to their hands or something so that it can be a little bit hotter and still have them squish up, like be able to
Okay.
squish them?
that
I
glove.
said gloves, yeah.
Pardon?
No, the gloves. Well, it's
Yeah,
dust.
still going ahead with that gloves. Yeah, and having that on while you're squishing the hot bag.
That
Yeah.
would be a good way to just PPE, you know.
Yeah.
Yeah.
Did it
Um,
feel like quite hot when you were squishing it, or?
If the first one
Mm,
definitely did, because I think a
Yeah.
lot of the heat was still hadn't permeated through the bag just yet.
Yeah. Okay.
So the bag itself was quite warm.
Yeah.
Whereas, yeah, later on, obviously, even as the water cooled, I think too, it didn't seem as hot. And I think the heat was more dispersed through through the Play-Doh.
Yeah. Okay.
I was going to say, either that or your hands just were conditioned to the heat after a while.
Yeah.
Mm,
I think one thing to point out too, pedagogy wise, is if I was doing this in my classroom, I would have it extremely structured. It would be an extremely structured lesson, even over doing the 2 activities over 2 different lessons. And the students would know what they're doing, what their expectation is each time, like at each point. Because I think it's something that if the students start to go off track, it could go off track really, really, really quickly.
You could definitely break that lesson into 2 lessons, with one being sedimentary and one being metamorphic, and you could take their samples overnight, and then the next day during a science class, they could use their samples, write their name on their little test tube straws, and then they could work on doing that the next day.
And that's a good documenting thing as well. Like, it shows a natural progression in progress in knowledge as well. I definitely agree. It's be a 2 lesson one.
Yeah, and even with the hot water one, the second one, trying to have an aid if it's possible, and it's someone else in the classroom
Yeah.
with you.
Just to monitor students as well.
Yeah, I think even referring to the straws as little test tubes is actually quite a nice thing, and the students would quite enjoy that little aspect of it, creating them making them little sciences to lesson. And you can see how then, I guess, keeping their samples in their straws, you could, make a presentation for our classroom and things like that to display their learning and I think Stephen said to document their learning as well.
That's something we could look at putting into our left-hand side potentially.
Yeah, definitely.
I think we discussed as well, though, for the graphing and everything. I'll get those images from over the course of the video, and I can send them through.
I already screenshotted the samples.
Oh, not the last one, but over, when we.
Oh, yeah.
Yeah. If you wanted them, that is Darcy. I'm not pushing you.
No, I will definitely take those.
Ready.
All right,
Very
should we stop the recording and then we'll have
All right. Well, that's recording done and dusted. This has been Unknown Factors. See you next time.